Hi, morning, guys. Well, yeah, all right. So, good morning and welcome back to another round of Steel Connect webinar. So, I'm Rocky and your host today to talk about steel and building related topic. Um, yeah. So today's topic will be about what exactly are standards and certifications, and why does it matter to you, right? So before I jump into the topic, so again, reminder for those LAM and also BM members who join us today, you will be able to submit the survey form and also your LAM membership number at the end of the session. All right, so don't worry about it, and the link will also be posted to you later. All right, so let's just start. Okay, so what are standards exactly, right? Because I think a lot of people, when they look at all these documents or standards, they are often puzzled by the reference. Okay, so standards, as explained, as we did this research and to find out more about what other standards are out there, right? It's actually a form of guideline, right, developed by different parties. Okay, and so of course, in Malaysia, standards are actually owned by this government agency called Department of Standard Malaysia, or DSM, right? So their mission is essentially, as you can see here, is to provide credible standardization and accreditation services to facilitate international trades, develop in industry competitiveness towards and enhance economic growth, societal and environmental well-being. So in essence, the name suggests, right, it's a standards where everyone speaks the same language, right? Where the product produced across different region are complying to a known standard. Okay, so of course, as the owner of the standards, of course, there will also be user of the standard. So the primary user of the standards will be someone like certification bodies, right? Who uses it to certify or even conduct testings, right? So one example that is popular in Malaysia is SIRIM. So I actually searched up on their website. So this is their mission, actually to provide innovative solution through testing, inspection, and certification services for their customers to be globally competitive. So I think the keyword, as I highlighted here, are testing, inspection, and certification services. So all this actually requires some sort of guideline, right? So that guideline itself essentially is a standard. Okay, so of course, how it affects producers, right, or manufacturers like us is that once we produce the product, we have to have a certain internal guideline ourselves. So it will be very convenient, or for established ones, it will be following or complying at least to the established standards that is recognized. So those products or processes will be certified by an accredited certification body like SIRIM. And SIRIM will be, would have been already accredited by the government agency or any body within each country to say that they are able to provide such certifications or testing services, right? So they are competent to do so, right? So that is different levels of how a standard is used, right? So if let's say it's being accredited, then it's being accredited to a different type of services as well. Okay, so of course in Malaysia, just I mentioned, there are Malaysian standards, and statistically based on the website, there are more than 4,500 Malaysian standards. Okay, so of course compared to other countries, for example Australia, they have more than 6,000 Australian standards developed. Okay, so it could be covering more say scopes. Okay, and of course one of the biggest one or most common one will be ISO, right, which is an international standard. So based on the stats, they have is published and valid more than 22,700 standards, right? And you might imagine, so many standards, how do you actually catch up with all that? So there are ways where you can actually search for those standards and make sure that you get updated when the standard itself get revised or get taken down to be replaced with other standards. So there are subscription service for that. Okay, so of course, without diving deeper, let's just look into Malaysian standards documents. So these are the documents front page. Typically for Malaysian standard, this is how it looks like. It has a logo, right? I believe it's a MITI logo. And of course, the reference number and all that. Okay, so to be more specific for steel industry or cladding industry, relevant to us, it starts from a raw material, and the raw material itself needs to be complying to a standards or certified to a standards. That standard reference is MS2651. Right, then when it comes to our production, right, where we produce a specific type of metallic coated steel, then it needs to comply to MS1196. Of course, there are different types of metallic coating out there. So, but today I will not be sharing that here, right? But you can actually find that online. All right, the reference documents will be slightly different from MS1196, right? So from there, moving on to if let's say it's a painted product or pre-painted coated steel, then the reference is MS2383. Of course, in recent years, there is also a usage of MS2500, which is to a standards that controls the quality of the profile sheets, which today I will not be talking about for MS2500. So the extensive part will be in the middle, MS1196 and MS2383. Okay. So in every single document, normally how we start is by actually looking at the table of content. And the first thing that pops up is the scope of each standard. So it's really important for you to understand the scope, because sometimes the scope itself will tell you a lot about or whether you should proceed with reading all the other details, because most often the title itself cannot explain everything. Okay, so what happens is that you need to go down in detail, right? For example, MS2383, to look at how this standard will be used. So over here, MS2383, for example, is actually used to specify the performance requirements of what they call continuous organic coated or laminated flat steel. Right, there's actually that is a very technical term for painted or pre-painted product. Okay, and it also specifies it's for construction or finishing of buildings, right? Usage. And of course, there are actually other notes which I will highlight later on, right? So how is it important? Okay, so that is basically what a standard is for, right? For producer to produce according to that standard, and also for people to, for accredited body to certify those producer, right? And essentially have the same language, right? So that people can recognize it. And most often, what they, I'm sure audience, some of you might have asked for Serim cert. So that is what Serim cert entails, right? Serim certs, you need to be more specific sometimes in terms of what kind of product are you asking for the Serim cert for, right? And you need to specify the product brand, perhaps, because most often the certificate itself will also covers what brand is being certified. Okay, so moving on to the second part, which is about say the quality test of different standards. So under the standards, most often there are testing standards, but there is also standards that specify the requirements when you do production, right? So that is what quality test is for. Okay, so under these standards, right, of course, when we say metallic coated steel, just now I mentioned MS1196. Of course, there are actually other national standards that are also published and being used as well, because again, Malaysia, we have producers that might be based in other countries or producing from other countries, right? And they import. So the way to look at it is that each producer, they will actually follow perhaps their national standards when they produce. But if let's say they import into Malaysia, it needs to be following the imports regulation. So in those different government agency will specify what is the standard for you to certify your product to before you can actually import it into Malaysia. So most common, most intuitively, Malaysian standard will be used definitely. But of course, Malaysia, some other standards, as I mentioned, some other products, sorry, it might not have a Malaysian standard or dedicated Malaysian standard. That's why some product they might say take Japanese standard, right? They might take Australian standard, for example, or American standard. So these are the list of standards that I will be briefly talking about. Okay. So for the same type of product, which is metallic coated steel and type AZ. Okay. So of course, under this standard for metallic coated steel, it is purely talking about quality tests, right? So for metallic coated steel itself, there's no performance test, right? Which we will talk about later for the pre-painted product. So for metallic coated steel, it's only quality test. And under this test, I'll be just showing you these three key ones that I think is easy to understand, over this platform, right? So the first one is chemical composition, right? So chemical composition talks about the steel base, right? What is the composition of carbon, magnesium, phosphorus, and also sulfur in that steel? Okay, and of course in MS 1196, the percentage cannot be exceeding all these numbers that is showing on the screen. Okay, but if you compare across different national standards like American standards, Australian standards, and Japanese standards, the maximum allowable chemical composition for these three four components is different. Okay, so how it affects you is that it depends on the steel that you source from, right? If let's say the steel, the producer is not aware of this and then produce something with the chemical composition that exceeds some of these numbers, then it will not be complying to this standard, right? So of course, this chemical composition will have its own background story why it's set that way, because it will determine a lot of the mechanical properties or material properties of the of the steel itself, right? So I won't go into the reason why, okay? But just bear in mind, the first thing of the steel base is that the chemical composition itself needs to comply to all these maximum limit. All right. So the next one is about tensile test, right? So tensile test test for how what is the strength of this steel, right? When it's used for say cladding, right? So in the market there are actually various different grades of steel that is meant for different application, right? So of course, in the manufacturer, even in our factory itself, we'll have a dedicated tensile test machine. This is how it looks like, okay? And every production, right, will actually take a sample, right? So the sample itself is what we call dog bone sample, and this is how it looks like, lah. Okay, and so this one is taken from every batch of production, okay, and we actually fit it into the center of this machine, right? Here is a close-up, right? Just place it into the machine so it clamps from top and bottom, and the machine itself will start pulling the sample until it snaps, right? So this is a close-up, so you can see there's a clear detachment, basically when it snaps, when it fails. And from here, the machine itself, which is connected to a computer, will actually compute out what we call stress strain curve. And this stress strain curve will tell us, what is the mechanical property of the sample itself. or of the particular batch of product. Okay, and of course, again, this is all specified also in the standards, right? How high or so-called the stress it can withstand. Okay, so just to show you, so these are the two different examples, but I'm using the high tensile one, which is it's called G550 steel grade, right? Which is very common for Malaysian industry when it's used for external cladding. Okay, so different standards actually requires, okay, if you look here, the yield strength itself will be more or less there, but then you can see the minimum is, some is slightly higher, for example, GIS, right, 560 megapascal. Then for the rest is 550. But when it comes to tensile strength, it looks like, for Australian standard, it's only requiring 550 megapascal. All right, and for elongation, most of them do not require elongation for this steel grade, right? Probably because it's just, really high tensile. Okay, so it's not flexible enough, or so-called ductile enough. So that's why for this steel grade, there's no specific requirements. Okay, so that is tensile test, right? So this again is specified in different standards, but then again, like what you see here, it will be different in terms of the minimum tensile that it can the requirements, minimum requirements. Okay, so moving on to the third one, which is talking about coating mass test. So this is one of those that is most often, I would say, misunderstood because of when people ask for serum tests, when I ask further, the answer is that, okay, I just want some assurance that this product is of quality. So when they say of quality, right, the term quality can be very, very subjective. Let me just show you why. Right, before that, let me just explain to you how does coating mass test, how is coating mass test conducted in the factory, right? So and also specified in the standards, right? So most standards we approach this in this manner. So you have a full width coil, so you can see it just now the sample came from left hand side, right? So this is a full width coil, and then from this full width, which will normally be roll form, there will be 3 samples being taken from each side and then also in the center. So this is what we call triple spots, right? And those samples can be in this form or in rectangle form, right? Typically, in this so-called circle form will be much more easier, right? Because you can actually calculate the area of the sample. So what you can see here is normally we'll measure the disc area, right? So that will give you the the area of the disc. And from there, we remove the coating on both sides. And from there, we measure the weight of the one sample, which is with all the coating removed, the metallic coating removed. And then from there, we divide that, we subtract that weight difference, which represents the weight of the coating, divided by the area. So that gives us the coating mass, right, in grams per meter square, right? So of course, grams per meter square, those are actually defined under, this AZ, the number behind it, right? So I normally would use, say, A4 paper as an example. A4 paper, they have all this packaging and then they won't tell you what is the coating thickness, right? Because for paper, it's compressible, and then most of the time it's so thin that if you measure one point and another point, it will vary quite a lot compared to the thickness. So that's why same approach is applied to our industry, where the coating is not measured by thickness, right? It's measured by coating mass, which is in gram per meter square, or GSM, gram per square meter. So what you can see from this table is that for different standards, national standards, there are actually a list or so-called a range of coating mass, right? So and what you can see here is that Malaysian standards tend to have, the biggest, right, the widest range, and it also includes the lowest coating class, which is AZ50, AZ70, and so on, right? So come back to the question just I mentioned. When someone asked me, okay, when I just want a serum cert, I just want a certificate, product certificate, right? So you need to bear in mind, right? All these are within that cert. If let's say is certified, so you can have a product that is certified that is in AZ 150 or AZ 200 or all of these coating class that is commonly used in as a cladding and then can last quite long, to something like AZ 50, which normally for us we do not recommend it, right? AZ 70 also is not a long-term solution, right? So when it comes to defining it as a quality product, so you need to know, what is the coating class, rather than just asking, do you have a serum cert? Because those represents two different things. Okay. So just to simplify it, so you see the range, right? So the maximum seems like is around AZ200, which is one of the more common, maximum, except for ASTM tend to use pound and feet. So that's why you see a number that's odd, 210, right? And the lowest seems to be, quite big difference as well. Okay, so it depends on the standard that you certify it to. Okay, and the certification body, the way they communicate or certify your product is also highly dependent on the standards. If the standard requires it to be tested or requires is covered within the standard, then they will certify it. If let's say it's not covered within the standards, then they won't certify it. For example, if let's say you have a product in AZ 100 or AZ 50, and then you want it to be certified in to Australian standard, they will not certify it to Australian standards. Okay, so that is how straightforward it is. So of course, that is just for metallic coated steel. But when it comes to pre-painted coated steel, there are a whole range of national standards. Okay, just now I mentioned quite a lot of standards, so you need to have that specific reference. So earlier I mentioned MS2383 for pre-painted coated steel product in Malaysia, right? Malaysian standards. So American standards, Australian standards, these are the reference. Okay, so of course it has its own quality test, right? Which I will not bore you anymore because I think it is quite straightforward to understand. But what you need to know is just that you need to know the spec, right? What is the dry film thickness and so on, right? So these are the quality tests that is normally done in the factory on every single batch. But what is not normally done is what we call performance tests. So this is something that I want to touch much more on, because I think there are a lot of misunderstanding on this performance test front. All right, so let's get into the performance test of different standards. All right, so the first one that I would like to highlight, of course, humidity resistance is quite straightforward, which has only one testing hour, which is 500 hours. So there's no difference there. And then the requirement itself is quite low per se. And the second one that, the paint durability test is most often overlooked in other standards. So that's why I would like to touch on paint durability test as well as corrosion resistance test today. Right, so as you can see from this list of different standards, it seems like only Australian standard is the one that requires paint durability test, whereas for Japanese and also Malaysian standard, it doesn't seem like it is the case. So again, the scope is that the test itself should determines how durable is the paint, right? So the intention is that you do not want the paint to last just like 2 years, 3 years, because once it's installed onto a building, the likely chance of you not wanting to replace it is very high, because you don't want any downtime if let's say it's a production floor, or you don't want to incur more cost to the building, right? To so-called replace it or to fix it. Okay, so what you ideally would want is consistency of the building appearance over time, right? The keyword here is over what period of time, right? So that requires a much more realistic testing, right? So how paint wears off is actually quite straightforward. Where you have a painted product, like what you can see here is a cross section view, and over time you have like different UV exposure in different locations, and also different rain intensity, different humidity, and so on. So this difference in terms of environment, external environment, would actually cause different rate of paint erosion. All right, so you can see the paint is actually slowly eroding, right, because of the weathering effect. Okay, so of course there are tests that are done in the lab, but again, when it comes to lab tests, right, there are actually very small chance that it can be replicated as real as it is in the actual weather. So normally in the Australian standards, they would require the product to be tested in outdoor exposure, right? So one of the reason why is because if let's say you recreate it in the lab, the likely chance of you recreating one environment is very high. But if you look at the entire world, right, different part of the world would have different UV irradiant, what they call UV irradiation intensity, meaning different part of the world, you use the same product, right? It would actually wear off very, very differently. The color would appear very differently if let's say you put it back together after maybe X amount of years, like 5 years. The appearance where the color would have, in a much more higher UV irradiation intensity would be, it will be changed much more compared to location with low UV irradiation intensity, right? For example, like in Russia or in Canada, where most of the year is quite gloomy, it's not very, very sunny. Okay, compared to places like South Africa, or even you see here, one of the reddest, Australia. Okay, so of course, having said that, we actually, under the Australian standards, they actually have specified where are the severe UV sites. Okay, and of course, not just in Australia that we do it, but in Malaysia also we actually set up a exposure site, because there are different level of UV irradiation intensity, like I mentioned. So it would react differently in different part of the world. So that is data that you have to get from different suppliers to make sure that the same specific specs, and also ideally, if let's say the same color, would be able to perform in such environment. Okay, so of course the data will be collected, ideally will be yearly, or otherwise depending on what is the duration that you're asking or you're interested to know. Okay, so some of the results, as what you can see here, is we would expose two different specs, but then it appears same color, right? But it ends up having a different fading rate, right? This is something that we aim to do, right? Even though it appears the same at the beginning, right? If let's say there's no such test, then you would not learn about how does the paint formula affects the durability. Okay, so this is another one, and most of the time there are common perception that says, okay, if let's say the color is much more intense, okay, it will be a good product, right? If let's say it's less intense, light, then oh no, it's not good, right? But here what you can see that it's not necessarily the case, where the more intense color seems in this case fade faster than lighter color. Again, this does not apply to across the board, yeah, because what I'm trying to show here is how this outdoor exposure test give us the result, and it's much more realistic than any lab tests, right? So the key components that affects it will be the type of resin and also the type of pigment being selected for each color. And please note that, you know, even though, you know, you ask for the same color from different supplier, you know, cost could be one of the factors for you to make decision. But bear in mind, there's another side of it, which is the performance. So bear in mind to ask for outdoor exposure test results if they have those results, and make sure that, you know, you ask for more details, like, you know, whether it's the same resin, same type of pigment, and so on, right? So those are things that you need to ask, right? That it's not applied across the board, because there are so many colors out there. There are so many different type of resins, pigments out there. So the best way to do is get assurance, right? And that is quite straightforward, because paint durability test, you know, it's just done by the Australian standards. There's no other standards that are doing it more conclusive, more thoroughly. But when it comes to corrosion resistance, there are actually different tests that are established, which this part is, you know, where most of the confusion comes in. I'm sure you have heard, you know, many different versions. I mean, there's no wrong version of it, but it's just how is it presented to you, and whether you have seen all sides of the story or not. So let me just present you, you know, what we have learned about this salt spray test and cyclic corrosion. All right, so SST and CCT essentially means salt spray and cyclic corrosion, but later on I'll have it in writing. So coastal areas like, you know, in Malaysia or in South Africa or in Australia, right, or any part of the world, I mean, where there's sea, there's always what you call sea spray or salt spray, where the sea breeze will bring up a certain level of salt particles, and that create an environment that is more corrosive, right? Of course, there are other factors like industrial emissions and whatnot, which historically you can look at, you know, your country's meteorological data. So this is one that was done in Malaysia, but it was just a graphical thing. There was not really a lot of data that can be derived from it, and from those graphical, the research paper derived it into this, where they actually classify, you know, different locations, different corrosivity. And what you can see from here is that they actually neglect, you know, the coastal line, and it seems like it's measuring mainly on the industrial, you know, emissions. And if I look at other countries' corrosivity mapping, like Australia, they actually map it also including the coastline factor in place, where just like I mentioned, sea spray, right, salt spray. So certain part you can see from here, the red borders is thinner, which is representing 1 km away from coastline. And something like this could represent 10 km away from the coastline, right? And the difference here is that, you know, if let's say the same product, you place it within the red border or away from the red border, the lifespan will be very different. Okay, and of course, in the Australian standards, they also list down where are the testing sites and what are the corrosion classification, which I will talk about later on. And intuitively, you can see that here the x-axis represents how far is it from coastline. So the closer it is to coastline, the more corrosive it is, right? Where the further it is, especially after the 1 km mark, the corrosivity drastically of the environment drastically reduced. Right, this is another one in South Africa that was done years ago. I would say decades ago, and that's why it's old data. So over here, they actually classify it, you know, whether it's dry or whether it's subtropical or whether it's you know, coastal region. So, and of course, in recent years, there also there was a group of researchers that redid the same measurement, and again they compute out more or less the same graph, where the closer it is to sea, the more corrosive it is, right? So in essence, if let's say your building is say 200 meters away from, you know, a coastline, compared to it being 1,000 meters away from coastline, then the corrosivity of the building located 1,000 meters or 1 km away from the coastline will be less corrosive. All right, so how does this matter, right? And how does it link to those different standards? Okay, so this is where the confusion comes in. So just I mentioned the salt spray test, cyclic corrosion, right? So salt spray SST means salt spray test. So cyclic corrosion has a certain level of similarity to the salt spray test, but there are variations that differentiate it from salt spray test. And of course, there is also outdoor exposure test, which without any saying is the most realistic one because again, it's outdoor, right? You just place it there, expose it for years, and then collect data. So the thing to be debated about is salt spray and cyclic corrosion, because these are what we call essentially simulations, right? So of course, traditionally, these salt spray test, which is a widely used test, it was not just done for cladding, it was also done for, say, in this example, door frames standard, right? So I didn't highlight or maximize the standard because it's just an example, but you can definitely find it. It's actually I think British standard, right? So over here you can see the corrosion classification, corrosion resistant classification of door frame application. Different types of material. What is the corrosion resistance classification? Over here you can see grade 5 being the term is called exceptionally high corrosion resistance, and this is actually a direct quote from the standard itself. Exceptionally high corrosion resistance. And if you use this term and then you look at the salt spray test, the salt spray hour is only 480 hours. Exceptionally high corrosion resistance, right? And if you look at the cladding, external cladding application, right, where the classification is more of a C1 to C5, and at C5 they have -I or -M, which represents industrial or geothermal or marine. Okay, so now I show you the salt spray test duration. So C5, which is very high corrosion resistance, or in the environment of high corrosivity, the salt spray hours is 2,000, right? So it's much more severe in a way, right? The simulation is much more severe. And just now, so-called the very, very high, exceptionally high corrosion resistance, it falls only around the C3 category. So that is the level of disparity, in terms of classification. But within the standard itself, there are some discrepancy as well. So over here, I'm showing you the salt spray durations, and I'm also showing you the cyclic corrosion resistance. Right over here, you can see C3, which is 1,000 hours, as opposed to salt spray of 500 hours. And then C5 originally was 2,000. Now cyclic corrosion is 4,000 hours. So I will explain later on what are the difference in terms of these two tests, and also what are the results that you can use from these two tests, and of course how realistic it is. That is the final answer questions that I think most of you might have in your mind, right? Why are you telling us these different type of tests, right? So let me just get into it. So SST, salt spray test, and CCT, cyclic corrosions, essentially are a simulated environment test, right? So they put the sample, as well, you can see these blue and orange samples in the chamber, and then there's actually a nozzle, a spray nozzle, where it was actually spray out a certain type of solution, right? So to simulate more corrosive environment. And the way they classify as whether the product can last for C2 out, C2, C3, C4, and so on, is based on the duration of the tests, which I have shown earlier, which I will also revisit later. All right, so let's talk about salt spray test first. Salt spray test also has its own standards. All right, so there's American standards, ASTM B117. There's also international standards, as you can see here, ISO 9227. Right, Australian standard also, there's a much more granular one, I think AS2331 dot something. Right, all these points towards salt spray test. right? There are slight variation to it. So again, we have to be specific when it comes to talking about all these test methods. Even in the production test, right, they also specify which test that they want to follow. So, but generally, right, this is super general. This is what salt spray test condition would be, right? Where in the nozzle, when they spray out the solution, it contains 5% of NaCl, which is 5% of salt. So meaning in your solution, spray out from the nozzle, there's 5% solution, right? And the temperature of the chamber itself will be 35 degrees Celsius. And it will be 250 hours of wetting hour, meaning the spray would go on and spray for 250 hours. And if you want, for example, 1,000 hours or 500 hours or 2,000 hours, then they will go on to do that continuously, right? And you might yield result like this, right? So 500, 1,000, 1,500, and 2,000. So of course it gets more corroded over time. Okay, but it yields the corrosion result. But the question now is it realistic? Okay, so it yields corrosion does not mean it shows the worst case scenario, because we have actually seen a lot of examples where it does not. So before I go on and show that, let me just tell you what. Salt spray test has no direct correlation with outdoor exposure test. And why I say this is because in the test method itself, right? Take what, for example, ASTM B117. It actually mentioned, the practice provided in controlled corrosive environment, which has been utilized to produce relative corrosion resistance information for specimen of metals and coated metals exposed in a given test chamber. And the prediction of performance in nature, a natural environment, has seldom been correlated to salt spray results when used as standalone data. Okay, meaning if you use salt spray test results as a standalone data, it has seldom yielded, a relevant result in natural environment. And the correlation and extrapolation of corrosion performance based on exposure to the test environment provided by this practice are not always predictable, which later on I'll share some example. And last, the correlation and extrapolation should only be considered if it has a certain level of appropriate corroborating long-term outdoor exposure data collected. Meaning, salt spray test by itself should not be taken as a realistic result unless it has a corroborating outdoor exposure test. And this is not unique. This warning is not unique to the test standard itself, because Australian standards, international standards also put out the same warning for the salt spray test. But this is most often left out when it's discussed about, meaning when people teach you, show you about salt spray test, okay, this is how it looks like, the severity of the corrosion, and it passed, right? But it has not seldom been presented with the outdoor exposure test. So that's why all these salt spray test results should be and must be taken with a grain of salt. I mean, pun intended, right? So should be, have some doubt in the salt spray test data alone. Otherwise, there'll be a shortfall in terms of purely relying on that data, and you get something like this. And mind you, this is a non-corrosive environment, and then the roof itself started corroding very badly, right? So that is a consequence. Okay, on the other hand, I wouldn't say totally different from salt spray tests would be cyclic corrosion tests. Cyclic corrosion test employs a certain level of salt spray test, as what you can see from the cycle. It also employs what they call drying cycle and wetting cycle, where it will expose the samples to not just salt spray, but it will dry up the sample, and then also a wetting cycle. Okay, and consistently, I mean, I wouldn't say always consistent, but again, compared to salt spray, there are some data that it compares between soft spray and cyclic corrosion with the outdoor exposure, and this is how it looks like, right? So prohesion, as what you can see here, is actually a type of cyclic corrosion test, and exterior means outdoor exposure test, right? So left is outdoor exposure, prohesion is cyclic corrosion, and soft spray is on the right. And what you can see here is that soft spray test seems to show some sign of rust, okay, but it deviates from the results that is shown in the outdoor exposure, only 14 months. Yeah. If this is not enough, then there's another result where soft spray test of 600 hours actually is worse off when it's compared to the outdoor exposure of 4 years, right? Compared to cyclic corrosion seems like not very severe. So when people see this, right, I mean, there is always a confirmation bias that say, oh, does it mean soft spray test will be much more severe? The result I see will be the worst of it can be. If let's say you're just seeing this, right? But if let's say you see more data, it is not always the case. Okay, so this is a research that some of the extract I taken out from one of the Japanese research paper. On the left is actually the outdoor exposure again, cyclic corrosion in the middle, and soft spray on the right. And what you can see from here is that outdoor exposure of 2 years, near the coast, yielded more severe results compared to soft spray. Okay, and soft spray seems like it has very little blister. It's not as severe as what is in actual. So from here, one of the conclusions you can, or prelim conclusion that you can think of is that how can I rely on this soft spray test? If let's say should I rely on the soft spray test if let's say I want to use it in actual building, right? So that is leave for everyone to judge here, right? But personally, me, I wouldn't rely solely on soft spray test based on what I've seen so far, right? So coming back to say the outdoor exposure test and also environment classification, of course, just now I showed you Australia's corrosivity mapping. They actually have classified different exposure sites. In fact, they have different exposure sites where they classify it based on ISO 9223, the classification, right? C2, C3, C4, and so on. So C2 site, this is how it looks like. C4 site, this is how it looks like. And then it is near to coastal, right? And the reason why they have all these testing sites is because it will actually yield much more severe result if let's say it's placed in C4. So for example, these 3 samples are actually the same product spec, the same product, but they was cut into different part and placed in different environment. And when it's time to judge, right, you can see that the result of the product placed in C4 started corroding. So what it means is that it is not suitable to be used for C4 based on the test duration, right? C3, C2 might be still possible. All right, so again, we also have conducted so much testing, and of course, we also compared with cyclic corrosion and soft spray test, and these are specific product used for cladding. Okay, the earlier one, it could be used for marine and so on, but this specific example that I'm showing you now is used for cladding. And the top is the outdoor exposure test, right? And the bottom, I'll give like maybe 5 seconds for you to guess, right? Which one is soft spray test and which one is cyclic corrosion. So based on what we learned just now, right, you might have some hint already that the left side is cyclic corrosion and the right side is soft spray test, right? So this shows that not often does a soft spray test show a much more severe result. Okay, and the intention here is not to look at the worst result out of the simulated test, rather which one is more realistic to the actual. And this is another one where soft spray test, you can see again, seems like it is yielding worse result, but in cyclic corrosion and outdoor, it doesn't seem like the case. Okay, so after I've gone through such a big round, coming back to the standards, the reason why I share all that is because in the revised MS2383 standard, the latest 2020 version, they have actually included salt spray test and cyclic corrosion in the tests. But for product to be classified under C4 or C5, the so-called the manufacturer can choose to conduct either salt spray test or cyclic corrosion test. This is where the danger happens, where the confusion happens. So I just make a table for you to have a better imagination, right? So if let's say the product is to be classified as C2 and C3, it can be tested in soft spray test and alone, right? Because the environment itself is not as corrosive. Okay, so most often the soft spray test itself will use corroborating data as the outdoor exposure, but not always, mind you, not always, because there are specs out there that do not even, I mean, it's not even suitable, but then can or might pass this soft spray test. Again, based on what we saw. Okay, but when it comes to cyclic corrosion, right, here you can see actually at different hours, C4, C5, C4 being 1000 hours of soft spray, and then C4 for cyclic corrosion is 2000 hours, which is double the hour. Okay, and double the hour doesn't mean the soft spray duration is higher. It actually means that it has 1000 soft spray hour, and then the rest is the mix of dry and wet cycle, depending on the type of cycle. But that is the ratio, yeah, 1000 hours soft spray and 1000 hours of drying and wetting. And most often when tester like Serim, they conduct all these tests. Just put it in context. They charge by the hour, how many hours you utilize the machine. For example, 1 hour they could charge 10 ringgit. Then for soft spray test, it will be 10,000 for 10,000 ringgit for that 1,000 hours. Same thing, they would also charge 10 ringgit for cyclic corrosion hour. So that would be 20,000. So if you are a manufacturer, you are incentivized to conduct a shorter amount of test hours, right? Because you pay less for the same classification of product. I can conduct salt spray tests and pay half the amount and classify as C4, right? But again, the question now is, does it represent the actual environment? That is for you to ask, for you to judge, right? Based on what I presented. Again, recap the scope. It is to actually look at the performance, right? Corrosion resistance. And just now I highlighted the scope at the top, right? At the bottom, there's a note. The performance of the coating will be highly, it will be dependent on the corrosion resistance of the substrate in the particular environment. So here, let me just show you the difference of the same substrate that is tested in salt spray test as is tested in cyclic corrosion in the same product category, which is C4. Same specs, yeah. One that is tested in salt spray, C4 is 1000 hours. But if you test it in cyclic corrosion, it will be 2000 hours. And this is how it looks like. And you might pause and want to recap what I just mentioned earlier. What I've shown you earlier, that cyclic corrosion had proven consistently that it will show closer results to the actual outcome compared to soft spray. But there's a dilemma again about payment of the tests. People are incentivized to pay less for the same classification. So at this juncture, the certificate itself will not mention whether it's tested in soft spray test or cyclic corrosion for C4 category. So it is for you as a consumer, as a specifier, to ask for all this information, right? So that is why the reason of this platform is to let you be aware of the information, right? So that you do not, you know the information now, so you can ask for the right so-called requirements. Okay, so I'll leave you to this final note that I thought about, is that when a product A that's certified to the same standard performs similar, would it perform similarly to product B that's certified to the same standard under the same product category? So of course, my answer, I'm not gonna force you to have the same answer, but my answer would be, I need to look at the result. I need to look at the source spray test, the cyclic corrosion, ideally, if let's say possible, the outdoor exposure tests. I mean, that is my conclusion, right? And of course, I hope you have the same input as, same learning as me when I prepared for this topic. And of course, just to cap it, just to summarize it all, what I've covered today, which you can revisit the video through our YouTube channel, is that for a standard, you need to look at the scope, right? What is the scope of the this standard? Whether it be testing, whether it be product, production related, or it be inspection related, like ISO 9001, which is for a system, right? Quality system, right? So that is where you can identify the standard usage in the scope. Normally, it will be at the very beginning. Then the second point that I've covered is that, for production standards, there is a part where it is about quality specs and requirements. So you need to ask for the specs as well, not just looking at the product certification, because like I mentioned, the same certificate might cover product of the lower end and product of the higher end, right? So of course, this really is depending on your supplier, right? So you need to be asking all these questions in order to get the answer, right? So again, last would be the more realistic performance tests, which are all covered in the standards. But you need to know which standard, or which test itself yield much more consistent, realistic result, and based on whatever that I presented. So that is, for me, I would definitely look at outdoor exposure tests, which we have seen a lot based on our industry and based on our Malaysian market. There are a lot to be studied, right, about different buildings around Malaysia, of course, around the world as well, right? So those are data that the supplier should be ready to furnish you with, and not just soft spray tests. Okay, so with that, I would like to move on to the question and answer section. And again, just a reminder, if let's say you have any question, please feel free to post it in the Q&A box, and I'll get to it shortly. Anyone? Or maybe it's too much to be digested for this session, too technical or too specific. All right. Yeah. Anyway, if I'm looking at the Q&A box. But I don't see any questions coming in. Cindy, maybe you can check. Is there any issue, because I don't see any. Yeah, I can see one. Can I say the material that's certified to C5 is suitable for corrosive environment without material failure? Okay, from Link. So Link, so I think you're posting it for the audience. So yeah. So when the material itself is certified to C5, it might not be necessarily suitable to be used in that environment, right? So-called with the context of without material failure, because if let's say you use say a material that is certified to C5, in, say, for example, coastal region, then you have to consider what type of test has been done. Okay, and I think if let's say it's just purely based on source spray test, then you need to ask for more confirmation. For example, whether there's any corroborating outdoor test or actual reference in the actual environment where it has lasted for, say, X amount of years, depending on your expectation. If let's say the answer is no, then you make your judgment, right? Whether you want to trust really the source spray test alone. Okay, so of course, if let's say your corrosive environment is something like really corrosive, like for example, glove factories, right, which we have covered this topic previously, then the answer is those environment actually is not even C5, is even worse, because those kind of building, right, where corrosive substance comes from within, would be very unpredictable, and we have seen it in many cases, many scenarios. So in those kind of building, we cannot really classify under C5 or C4 or so on, because it's so unpredictable and it is subjected to building to building, right? Those C4, C5, those are general outdoor environment. Okay, so yeah, I hope that answer your question, or anyone who's having the same question. All right, Johan, I think, okay, yeah, Hizam, yeah, thanks for posting the question, Hizam. How is coating mass to be measured by the material purchaser in the case the roll former, to confirm that is according to the requirement? Is it sufficient to only rely on the mill cert provided by supplier? Hizam, I think you highlighted a really good question. So when a material arrives at your site as a roll former or purchaser, you can rely on the mill cert as a proof of what has been produced. And if let's say you have concern or so-called doubt about it, so my approach, which I would recommend, is to go back to the supplier and see whether they can actually recommend or tell you, okay, whether this is based on their system, whether it's the right spec. If you feel that is unreliable answer and you want to conduct a test, of course out there are a lot of accredited testing lab, what we call accredited test lab, that will be competent to do this coating mass test. And of course, you can take the sample and ask them to do the test based on a particular standard that the production or so-called the producer has stated in the mill cert. I'm sure the mill cert itself will also specify what is the standard that they follow, so that you can actually use the same standard to ask the third-party accredited lab test to conduct based on the standard. Okay, so I think maybe sometimes the purchaser does not have the standard, so you can actually buy it on Department of Standard Malaysia for those standards, right? Because it's quite cheap. I think one document is for Malaysian standards that I'm talking about is only what 45-50 ringgit, right, for this kind of standards. So you can actually have a detailed explanation in the standards. Yeah. So of course, if let's say the result is that okay, it is passed, then yeah, they in the accredited lab also, they will also specify what is the standard that is tested against. So you can use that as your proof lah, whether it is complying to the mill cert or not. Yeah. So any other questions? I think maybe the system is coming in slow. Okay, Johan. Have you found a big difference in the corrosion resistance performance between pre-painted and mill finish material, meaning without pre-painting? We have actually seen big difference. I mean, not big difference. I would say it is depending on context. No doubt, when it comes to pre-painted, there is actually an additional layer of paint to protect the substrate, be it metallic coated, or typically we call them galvanized steel, right? GI and so on. The painted version of it compared to the same substrate without paint, definitely the one with paint would perform better. When it comes to big difference, it is normally in the case of, if let's say it is in a much more corrosive environment, because in a much more corrosive environment, you have a situation where the galvanic coating might react faster, right? So having an additional paint barrier, which typically would be inert to all these kind of chemicals, would drastically improve the lifespan or corrosion resistance of the pre-painted product. Okay, so Johan, hope that answered your question. So Fong, how to clarify zone C2 and C3? So just now you saw, right, C2 and C3, those are less corrosive environments. So normally how we classify is that, if let's say it is away from marine, away from industrial area, then we'll classify as C2. And if let's say it is a much more urban area than C3, but these two are quite similar, quite close together, because if you look at the source spray test, the difference is not very big. So yeah, so normally we'll classify straight away under C3. For us, it makes no big difference, because I think based on whatever that we produce, that we promote out, it normally can, in actual, pass C3. Yeah. But again, if let's say you are talking about in Malaysia, there are no concerted effort in, reconducting all this research again on classifying the environment. So definitely, I think the meteorological department have to do something like that, because based on what I've researched, right, the cost of corrosion, I mean, as a country as a whole, right, is quite high if let's say you don't have all this in place to make sure that you classify accordingly and then use the right product or use the more suitable product. Of course, individually as a business, different people would benefit from using a not suitable product. I mean, people who benefit will be people who are selling it, but people who are using it would I mean, this is really a zero-sum game. People who are buying it, if let's say they don't know better, then they have to replace it. So that, in economic terms, make it an inefficient economy. Yeah. I think, Clarence, I mean, I hope those questions that are posted, we have addressed your question, but if not, then we will actually compile it and then answer to you by email. So yeah. And yeah, Fong. So let me just answer this one question first, Clarence. Any specific guidelines say how many km from coastal line will be considered C3, and how about the industrial zone? What manufacturing activities will be considered C3? So yeah, Fong, you actually touched on a very specific question. So for us, we, as the data shows, right, we follow the data from Australia, where 1 km away from coastline, we'll consider within the marine environment. Away from 1 km, we'll consider as C3. Okay. or even C2. But 1 km is the line that that is quite straightforward. But in Malaysia, there are some confusions because we have heard before cases where big clients themselves would use different documents to classify. For example, 5 km from coastal line will be considered as marine, right? C4 or C5, and then anything above that, anything beyond that, would be normal environment, right? So there are different classification, which if let's say you are bidding for the project, so you can always ask those questions, and you can always ask us as well, because I think we have a really clear-cut answer for you. And for industrial, however, it is always subjected to where is the location. For example, the building itself, if let's say it's located next to a glove factory, right, then naturally the environment will be more corrosive because of all the emission, right? So it's subjective because the factory, for example, glove factory, some would put in extra system to filter the emission, some might not, right? And some might have leakages and some might not. Okay, so the way we approach it is very personal. I think it's case-to-case basis, and ideally, if let's say those are the situation, which I would think not a lot, then we will go on site to actually study and give more tailored recommendation. That is our standard approach. So yeah, so it's quite clear cut for marine, but for industrial, it is always case to case, and we prefer it to be that way because, yeah, like I said, too many factors. All right, so with that, let me just go to the last page. Yeah, for those architects, engineers who are still around, you may scan the QR code that's on the screen, or I believe Cindy has posted the form link in the chat box. Okay, so you may submit your LAM or BEM so-called membership number, and we will actually submit it to the respective body to help you claim your points or hours. All right, so with that, thank you for joining Still Connect webinar, and we'll see you again next time. All right, thank you. Bye-bye.